Alright, looks like we're recording the class here. That's a good thing. Okay, today we are starting our trebuchet project, and I'm going to show you what that means. It's pretty straightforward, actually. We're going to actually be mirroring the project that my other engineering design class is doing. They're building a full-size trebuchet, where we will be building only a miniature one. So this is what they're doing in the other class next Saturday, and anybody who wants to come is welcome to come along. Let's come and watch. But next Saturday, the Engineering 1010 class, my physics class, and also one of the regional high schools is going to join us, and we're going to throw pumpkins using full-size maybe, but 6-foot tall trebuchets, which are kind of like catapults. We'll learn about those more today. And we're doing this for distance to see if we can throw a pumpkin the furthest. Last time I went to one of these, a 6-foot tall trebuchet threw a pumpkin 320 feet. And so it can be pretty amazing to watch if they do it right. Now they have some design parameters that they're in our competition. The cost of the materials cannot be more than $500. The height has to be less than 6 feet, and they must be portable. The machine will not have any pneumatic, electrical, or explosive components, so it can't be air powered, can't be electrically powered, can't have any, explosives. And they have to launch a 10-pound pumpkin, a 10-pound projectile, and to pass a safety inspection. Now, yours is going to be slightly different, and I'm going to go ahead and spell that out right here. Instead of the value of the materials not exceeding $500, you can only, there we go, that's a better way to say it, can only use materials provided. Right? The height for yours must be less than, let's see, 10 inches. There we go. Portability, of course, that's not going to be an issue with these miniature machines. Machine will not include pneumatic, electrical, or explosive components. Machine will be designed to launch a quarter-pound projectile. So how do you get a quarter-pound projectile? You have lots of different choices. You can get steel bearings or lead weights from the store, and little lead shot from the store, or from shotgun shells. You can get it, I guess. And you could fill up a little bean bag. There's all kinds of ways to get a quarter-pound projectile. It's not that difficult to do. Probably the easiest thing to do is to just go down to the store, or go to your fishing tackle box or your garage and make one out of some nails or some washers or something. You can tape them together and wrap them in tape so that they're not going to, when they fly around hitting things, they're not going to break anything. It's not that difficult to make a quarter-pound projectile. Not a lot of weight. I'm talking about the size of a McDonald's hamburger, or the weight of a McDonald's hamburger. Not that heavy. But it does need to be a 1/4 pound, which is 4 ounces. So, machine must pass a safety inspection. We're not going to worry about safety inspections because not that big of a deal for safety inspection when it comes to some things this small. But what we're trying to do here, let me fix something really quick. What we want to do is we want to be able to launch projectile more than 20 feet. We want to be able to shoot this thing over 20 feet. So if you're doing this in a classroom or something similar, it's about the width of the classroom or the length of the classroom, depending on the size of the classroom, but most classrooms are somewhere between 20 and 30 feet, so it should be able to go most of the distance of the classroom. Wherever you're doing it, though, you'll still need to measure it, so get a yardstick and some painter's tape or something and measure it out so that you can know exactly how far you've thrown, and or throw the object and mark where it lands and then measure, a tape measure or whatever. But that is what we're trying to do. You cannot include, the machine will not include pneumatic, electrical, or explosive, or I'm just going to actually take off the explosive and put on elastic. So you cannot use any elastic components. In other words, you can't use rubber bands, you can't use anything like that. So it kind of limits you to how you can build this thing. Okay, so now we kind of got the design parameters. Safety inspection is not going to be required for this particular thing, but I am going to use the same kind of parameters for essentially grading your design. It must be a good structure that's going to hold up to the launch. If you launch once and it breaks, no good. If it's wobbly and things like that, no good, that kind of stuff. So it definitely needs to pass these kinds of requirements, even though we're not going to have a safety test. And then what you're going to do at the end of it is you're going to do the same thing as they're going to do in their competition next weekend. You're going to launch your projectile for distance. You're going to get 3 launches and you're going to average them together, and you're going to tell me all 3 of the launch distances and your average, and that will also count towards part of your grade. So, you of course aren't going to need this registration form here. Let me 1/4 pound. And we won't be doing prizes, you'll just get graded. Now, since I can't really sit and watch you launch your projectiles and make sure that you're doing it, you're going to have the opportunity to get the best launches you can, but there is a deadline. This thing will be due next Wednesday. No, what's today? Today, Friday? Yes. This thing will be due next Wednesday. So you have to have everything done by next Wednesday. And essentially what that means is that it has to be done, turned in to me Wednesday, because on Wednesday you're going to put together presentations on what you actually did, which means you're also going to have to keep records of what you did. We'll talk about that in just a second. Here is the list of all the different types of things that you could possibly use And they have, I have things like trebuchets and catapults and ballistae and everything in here. However, you're not going to be able to use catapults or ballistae because they require the use of some elastic component. The only things you're going to be able to use in here are the trebuchets, really. So, let's take a look at some of this stuff, some of these websites. So, on SiegeEngine.com, they have plans and designs for micro trebuchets and different types of trebuchets. What is a trebuchet? A trebuchet is essentially the French version of the catapult. And the catapults were originally made by the Greeks, and they were pretty good weapons, but not nearly as good as the trebuchet. The idea of the trebuchet is that you have an axis here, and you have a counterweight, and you have a long throwing arm, and on the end of the throwing arm, usually, you have some kind of a basket that holds the thing that you're throwing. So so when this thing is all loaded and ready to fire, here's your counterweight up in the air on this short end of this throwing arm. The long end of the throwing arm goes all the way down here, and they've got it connected to a string here, and this string would be connected to usually some kind of cloth leather basket that holds whatever it is you're going to throw. And then when you release this, the weight comes down and the arm goes swinging up, and the string on the end of it swings around and really whips things a long way. And usually what you have is a hook on the end of this thing, and they just have a little groove in the wood, but usually you'll have a metal hook so that when it gets to a particular angle, the string slips off of it, or the rope slips off of the hook and throws the projectile at whatever angle is perfect for throwing. Usually you want to throw your thing at about a 30-degree angle, or between 30 and 60-degree angles, depending on the machine. But this is the idea of the trebuchet. Now this is the simplest type of trebuchet really out there. It's actually not the simplest, because this one has a swinging mass on the end of it. In other words, there's a little axis here that allows this mass to swing. So it's not the simplest one. The simplest one just has the mass connected on here, and it doesn't swing around. However, the swinging mass trebuchet is a little bit more efficient, throws things a little bit better. And there are others that are even more efficient, and we can show you all kinds of them. There's so many different types of trebuchets out there. So those are the simple trebuchets. Let's see if we can find one that's a little more complex. Here you can see one of these 6-foot tall ones that has a big counterweight on it. See, they've got exercise weights on the end of there. You can see this is the long end of the throwing arm down here, and their basket is down here. And when it throws around, it opens up this basket, and the thing comes flying out of the basket. Let's see if we can find. Let's go back to our paper here. Let's go to a different one. So here they have instructions, the same web page actually, SiegeEngine.com, it's under the engineering. They have instructions on how to build different things like the frames, the slings and the pouches, how to trigger it, so how to release it. Here they're doing stuff for torsion bundles, and that's for catapults and stuff that you're not going to use. And so they have some instructions there on that website, so you can put together some kind of a plan for building. And then there's this website here called trebuchetplans.com, where they do have all kinds of kits and things. Now you're not going to buy a kit, but these things can give you ideas. So if we go to all of our kits, they have them on CD, but you'll see pictures of them. So here's the trebuchet with the swinging mass on it. But here's what is called a floating arm trebuchet, where the whole arm of the trebuchet actually slides downward as it throws. And this is one of the most efficient types of trebuchets there is out there. It can throw things extremely long distances, but it is more complicated because you have this sliding mass arm thing going on. Here's a larger version of the floating arm trebuchet. Let's see if we can find some other ones. This one here actually uses some gears for winding it up. You probably won't need that one. But this one is kind of this one is like a scissor trebuchet. It's called an onager, and that one uses a scissor motion for the mast to move down. Also more complicated, but also more efficient. So they've got, let's see, what else do they have here? I guess that's it as far as trebuchets go. So they've got a couple of different trebuchets there that you can look at. And I guarantee you that if you build a floating arm trebuchet that works versus just a standard trebuchet that works, you're going to get a better grade with the floating arm trebuchet, whether or not you get the longest throw in the group, because that's going to require more planning, more engineering, more effort. So it's a lot of fun. There's a lot of cool stuff. Then we can go here to catapults.info. Let's see if we've got anything there that's. These are, so here's the trebuchet, another version of a trebuchet. They do some slingshot catapults, which we're not interested in. So they do have some stuff there. We go to the trebuchets portion of this, and it gives you some more pictures. But you can also go to onagers. Well, this one is actually they're just showing catapults essentially, so that's not it. But all these resources here will give you ideas on how to start. There's some YouTube videos. There's an instructables.com, how to make a trebuchet.blog.com, whatever blog. There's lots of different resources here on this page. Now I will email each of you this sheet that tells you what you're going to do, and I'll update all the information so it fits our class a little bit better. But I will email this to you today, and it will be your job to start a project in trebuchet building. Now, let's put in some details really quick just so I don't forget. So this is due Wednesday, and not by Wednesday at the beginning of the day. It's due Wednesday by class time. Alright? So get it done before Wednesday. And Wednesday is, what day is Wednesday? 22nd maybe? 23rd. So due Wednesday, October 23rd. By class time. What is due? What's going to be due is, you're kind of in a time crunch for this, but you're going to have design and build. I want this to be bold. Design and build a trebuchet. Also throw projectiles 3 times for distance and average. But the other thing that you're going to also have to do during this project is maintain a project logbook. I can spell out the good for each step of the process. So what is a project logbook? Alright, we won't need to do it in registration. And we don't need to do a machine design preliminary approval. However, what is a logbook? That's important for us. So logbooks our project logbooks contain all necessary information so that somebody else can read it and reproduce your project with similar results. Right? You do not need to record every single little thing you do in a project logbook. However, it should include specific things about the design process. It should include specific things on why you chose the design that you did. It should include the specifics of your design. It should have drawings. It should have pictures. It should have drawings that are labeled with lengths of pieces of wood and size of this and what material it's made of. How you put it together. Did you use wood glue? Did you use nails? Did you use something else? There should be maybe a step-by-step instructions for certain parts of the trebuchet that were maybe difficult, that required you did something just right or it didn't work out, right? It should be detailed enough that somebody can come in and reproduce your results, but not so detailed that it's just boring because you're talking about you hold the nail with your left hand and you hammer the nail with your right, right? So, also something that should be in here is that each time you work on the project, you should record something. Okay? Not just I worked on the product, it should be something important about what you accomplished. This keyboard is terrible for typing on. It's at a weird angle, I can't ever get my fingers in like this. Okay, so anyway, it should record something important about what you accomplished when you worked on the project at that point. Okay? You should not write up the logbook all at once at the end of the project. Okay, that's not okay. It needs to be a little bit at a time every time you work on it. So every time you work on this project, you should accomplish something important. So let's say you sit down today and you are researching the different ideas. You're looking on these websites. You're trying to decide what you're going to build. At the end of doing that, you should sit down and write in a logbook. You can write it by hand if you want to, or you can do it on a computer. Doesn't matter to me, but you should save it somewhere so you can keep writing it. And you should put down a date. You should put down what you did. Today, at 3 o'clock in the afternoon, I researched the different types of trebuchets so I can get started. And I decided that I like these 2 different types. And include links to those websites and maybe a sketch of those designs. And then to write a couple of sentences on why you like them. I like the floating arm trebuchet because it seems like it's going to be the most efficient design for throwing things, and it'll use all of my ingenuity and creativity to get it done. That is a challenge and I want to do it. Or I want to do the swinging arm trebuchet because it seems simple and I want to make something simple that will definitely work. Or whatever. But you should put down what you did, why you did it, and what was the result. Right? I found these two ideas. And maybe the next time you say, well, I've decided on the swinging arm trebuchet, and I'm going to start to put together a list of materials I think I'm going to need, and put those lists of materials in your logbook. Okay? And then maybe later on in the project, maybe next Tuesday, you're testing it and you're throwing things across the room. You say, I did 5 throws with my trebuchet. The trebuchet wasn't working properly on the first 2, so I changed something, and this is what I changed, this is how I changed it. And I worked on the last 3. These were my distances before the change. These were my distances after the change. And I'm thinking of maybe making one more improvement before I test this again, or something like that. And maybe take pictures of your testing, or maybe take a video, and you can include that in your logbook. If your logbook's electronic, it's easy to include things like that. If not, you just need to say, well, I made a video, and if you want to see it, talk to me. That kind of thing. But you should record your progress and record your results as much as you can without being overly zealous. You don't want to record everything possibly you did, but you do want to record enough information that somebody could reproduce what you accomplished. So that logbook will also be due on Wednesday. Okay? Then, after we're all said and done, after we're done with this project on Wednesday, we will have a presentation to do. And this presentation will essentially be your first exam, kind of. Your this first exam is going to be on your Chapter 3 stuff and kind of the engineering process in general. So everything that we've done between Chapter 1 and Chapter 3 has been about how to do engineering, and then Chapter 3 was about how to communicate engineering. Well, a presentation is all about that. So you're going to present what you did, from deciding what design you were going to use, to implementing the design and actually building it, to testing of the design, and you're going to do that in a presentation form. And you will have Wednesday and Friday to put together that presentation. I will give you some help doing that, show you some ideas on how to present, and give you some examples. But your job to get that done. So, that is the project for the next week and a half, essentially. This will take us all the way through next Friday, and then you'll turn in those presentations and we will start a new project after that. Does anybody have any questions about what we're doing here for the next little while? No. For the arm, the 10 inches goes to the pivot. So height less than 10 inches to the top of the pivot. Does that make sense? Yep. Okay, let's see, I'll save this as something for this class here. We'll go to our class. And I forget how Windows works. Alright, I will send that out to you guys all right after we're done here today, which we are done here today. That's all I have for you, really. But I will send this out to you, and you guys can go ahead and get started. The materials that are provided are your build kit. The only things that you can't use in there are the pneumatic components, of course, the hydraulic stuff, and you also cannot use your all the rubber bands and things like that. So everything else is fair game to use, and in the kit. The only other thing that you might need, that you'll need to add to the kit, is a counterweight. So whatever you want to make your counterweight out of to connect to the one side of your trebuchet doesn't matter to me. But that's the only thing that I didn't include in the kit is the counterweight materials. Unless you want to use washers and screws that I included in there. They're probably not quite heavy enough for what you want to do. As far as a quarter-pound object, other ideas for a quarter-pound object, I think a golf ball is about a quarter of a pound, although I'm not perfectly sure about that. You can get a golf ball and weigh it and see if it's about a quarter pound. If it's a quarter pound or more, you can use it, of course. If it's not quite a quarter pound, you can always drill a few holes in it and fill it with some lead weights or something. Put a couple pieces of lead shot in it or something. But anyway, you can use whatever you want for your throwing object as well. Just make sure if you're throwing in an area where there are breakable objects that you don't break anything. So, if there are no more questions, we can be done for today and you can be off and running. We good? All right. See you later. Do you have any questions for me, Tyler?
Just thinking about the materials I use for this project.